A tuning fork is used to produce resonance in a glass tube. The length of an air column in this tube can be adjusted by various pistons. At room temperature of 27 degrees Celsius, two successive resonances are produced at 20 cm and 73 cm of column length. If the frequency of the tuning fork is 320 Hz, the velocity of sound in air at 27 degrees Celsius is. So let's try to understand what this question is telling us. A tuning fork is used to produce in a resonance glass tube. Alright, so it is telling us that we have a tuning fork like this. It will produce resonance from a glass tube. Let's just say like this is a glass tube we have, and when the tuning fork will hit the glass tube, it will produce resonance. The length of the air column in this tube can be adjusted by various pistons. So the length can be adjusted. It is telling us at room temperature 27 degrees Celsius. At room temperature, we have two successive resonances produced at 20 centimeter and 73 centimeters of column length. So we have two resonance, let's say L1 as 20 and L2 as 73. Both are in centimeters. We don't need to convert them. We need to convert them of column length, because the length is considered as meters ideally. And if the frequency of tuning fork is 320 Hz, we have given the initial frequency, which is this frequency is 320 Hz, the velocity of sound. So we need to find the velocity. How we can find the velocity? There's a simple formula. When the tuning fork will hit the glass tube, it will go from a velocity, the sound will go into the sound. So we need to find the velocity of the sound at 27 degrees Celsius, which is the ideal room temperature. So there is a formula for that, that is twice of frequency into both the resonance. Will subtract the both resonance, L2 minus L1. Here we can see this in this, and we are converting this resonance power into meters, so 10 power minus 2. So by calculating, we will come to this, it will come to like meter per second, that is 339 meter per seconds. So here we have the solution of 339 meter per seconds.